Today we're going to talk about potential energy. The meme here on the left side says, "My physics teacher said I had potential, and then he pushed me off a building." By the end of this lesson, you should be able to explain to Mrs. Domingo what this meme is representing or talking about. Our state standard that we're going to be hitting today is that there are different types of potential energy, and we're going to focus on gravitational potential, elastic potential, chemical potential, electrical potential, and magnetic potential energy. By the end of class, you need to be able to explain what has an effect on gravitational, chemical, magnetic, elastic, and electrical potential energies. Now, before we can discuss potential energy, we need to understand what energy is. We define that as the ability to do work, or cause something to move, or cause some kind of a change. We measure energy in joules. Now, Garfield here is the epitome of conserving energy. He's very lazy. He doesn't want to put forth any energy to really do much but sleep all day. Two types of energy. We saw in that first little video that there are two types. We've got kinetic and potential. Kinetic energy is energy that the object has because it is in motion or it's moving. Now, the kinetic energy of an object is affected by the mass of the object. We know that the more mass it has, the more kinetic energy it has. Also, the velocity of the object. If it has more velocity, it has more kinetic energy. Now, remember back from forces in motion when we studied that velocity is just how fast is it going and in what direction is it moving. So the faster it's moving, the more kinetic energy it has. Potential energy is what we say is stored energy. It's held in readiness. It's not doing any work or causing a change at the moment, but it could possibly. The reason objects have potential energy is because of their position or the condition of the object. So where is it located, or if it were like a spring, is it compressed or is it stretched? So the condition of the object. We're going to be focusing on gravitational, elastic, chemical, electrical, and magnetic potential energies today. In this first picture here, we have a boy riding the bike. He is using kinetic energy. As he is moving up the hill, he has kinetic energy. At the top, he stops. At the top of the hill, he has used the kinetic energy and has transformed it into potential energy. As he's standing there, no work is being done, so he has that potential energy. And we saw in our car and ramp lab that the higher you are off the ground, the more potential energy you have. As he comes back down the hill, his kinetic energy is starting to become more and more because the potential energy is being transformed into the kinetic energy. The simulation we have shows how this works. In the middle, we have the potential and kinetic energy. It's going to be a pie graph or pie chart. As this roller coaster goes up the hill, it's going to have more and more and more kinetic energy and potential energy until it gets to the top. And then as it comes down, it's going to change the potential energy, because it's coming closer and closer to the ground, into kinetic energy. And that's where this roller coaster starts to get faster and faster and faster until it hits the bottom of the hill where it is at its fastest point. So down here at the bottom, it is all kinetic energy and very little potential energy because it's down near the bottom. As we go around the loop, it starts to have more potential energy as it gets higher and higher and higher, and that kinetic energy is starting to turn into potential. Once we're at the top of the loop, we don't have as much potential energy as we did at the top of that first hill because we're not as high up in the air. Watch as the potential energy switches back to kinetic as that roller coaster starts to speed up again as it comes around. Again, we're down at the bottom, so we have kinetic energy, no potential energy because we're down at the very bottom. Then we go up the hill again, and again, this point is not nearly as high as point 1 was when we were on the top of that hill. So this has some potential energy, but not a whole lot. And the kinetic energy that we're going to get from this hill is not going to be very much. All right, back to the notes here. In these pictures, I would like for you to try and figure out which one is potential and which one's kinetic. Go ahead and pause the video for a second and identify which picture for each pair is potential and which one is kinetic. All right, hopefully you have identified those. This first one here, the bow is moving, the arrow has been shot, so this would be kinetic. In this picture here on the right with the bow and arrow, we have the person pulling it back and holding it, meaning it has the potential to move. It has stored energy in the bowstring, and it is going to be considered potential energy. Here we have the ball being dropped. The first one, it's held in readiness up off the ground, and that would be potential. And this one where the ball is falling, that would be kinetic. With the hammer held up high in the air has potential. And then the one next to it with the arrow showing that it is moving down towards the head of that nail, that would be kinetic because the hammer is moving. So in our car lab, we realized that potential energy depends on the position of the object relative to the earth. If it is higher off the ground, it has more gravitational potential energy. We also found out in that car lab that the more mass it has, the more gravitational potential energy the object will have. The thing about playing with a rubber band, potential energy that is associated with objects that can be stretched like a rubber band or compressed like a spring would be elastic potential energy. The more you stretch it or the more you squeeze it together, the more stored energy it has. Basically, it has a further distance to go back to its rest position. The further it's stretched or the further it's compressed. It has more energy that will be released as it goes back. So it has more stored or potential energy. So in this example over here on the right, we have the equilibrium position. That means what it would be at rest. If we compress it, that gives us some elastic potential energy. Or you could stretch the spring and it would have elastic potential energy. As we watch this Wile E. Coyote video, I want you to watch for some examples of elastic and gravitational potential energy. That poor Wile E. Coyote, he never gets a break. He never can catch the Roadrunner. Some other examples where we have elastic potential energy. You're probably all familiar with Katniss from the Hunger Games. She shoots those bows and arrows. We also have, this is just kind of funny down here. It says engineers, or how engineers play Angry Birds, and it's a bunch of calculations showing how they would come up with their trajectories for playing Angry Birds.